Analyzers, and welcome to the Chapter 2, Lesson 4 notes. We are going to graph absolute value functions today. And this year, I know that for those of you who had me for Algebra 1, I introduced this back in Chapter 3 of Algebra 1, where I give you the absolute value parent function, and then I give you the general form of the absolute value function, and I show you how you can figure out your vertex and your slope based on looking at just the equation. Well, now we're really going to focus in on that. Okay, so we're just going to go back through. Remember, absolute value is just talking about a distance, and distance isn't positive or negative. Okay, you don't say, oh, I drove 30 miles west. Let me take the west out. I drove 30 miles and I drove negative. That didn't make any sense. You're not driving negative 30 miles, you're driving 30 miles. I said west because that's the direction. Just like positive and negative are technically just the direction of the number line you're headed from zero. Okay, so when you talk about absolute value, you're talking about just not having the sign present because we don't care which way away from zero we are. We only care about the distance away from zero we are. And that's what absolute value is. Now, when you start to put two variables involved in that, then absolute value looks like a V shape. Okay, and that's what happens. And so here, what I'm doing in the absolute value function, okay, is I'm showing you this is the general form of the function, right? So y equals a, and then the absolute value of x minus h plus k. Now, just like with circles and quadratics, as we'll find, this is the opposite sign of the actual vertex point value. This is the correct sign of the actual vertex point value. So inside is always going to be the wrong sign. It's the opposite sign of what it actually is. Outside is always going to be the correct sign of what it actually is. So what does that look like? Right now, if I just take this form and plug in the zeros and the 1 where the a is, and so expand out my basic absolute value function of y equals x, I can see that my vertex is 0, 0, and my slope is 1. And since the positive 1, it's going this direction. That slope is always what's on the right of your vertex, okay? And so here's my vertex at 0, 0, up 1, right 1. Now, from the vertex, what I know is I do the opposite on the other side. So I've already got this going. Cool. I know I need a V for absolute value. It goes this way now. It's the opposite on this side. That's what's happening with absolute value. And that's what we're investigating when we're looking at these. Now, again, you always have your graphing calculator, so you don't absolutely have to know what this, what absolute values equation is saying, because you'll always have this backup plan. But it's so much faster when I can look at the equation and know exactly where the vertex is and exactly what the slope from there is going to be. Okay, so it is just easier if you can interpret that function equation right off the bat. So let's start. I'm going to go from our parent function of y equals the absolute value of x, this blue one right here, to the end right here, this red one. Okay, and in each section, I'm changing where I'm looking. Okay, so I'm moving, starting with our parent function right here. So there we are, blue, starting with our parent function. Now what I'm going to do is I'm going to move this function right 3. Okay, that means that what I do is I put in a value of -3 inside the absolute value bars. And the reason I say that is because remember, the basics of that function have to have an x minus h on the inside, h being the x value of our vertex. So if I need this to be a +3 and it's going to be minus in here, I insert a -3 right there. Boom, now all of a sudden, you're going to have a +3 that's coming out. So 3, 0 is now my vertex. Notice my slope stayed the same. Okay, next thing I'm going to do is I'm going to stretch it up like that. Make it narrower. So in order to do that, I need to increase my slope. My slope was 1, up 1, right 1, up 1, right 1, up 1, right 1. Now I need the slope to go up 2, right 1, up 2, right 1. So what goes in front of my absolute value bars this time? A positive 2. Now again, on the other side of the vertex, you do just the opposite. Okay, so you know how to go the other direction. But that is how we increase the slope, making it narrower. Last, let's move this vertex up. And we go up 4 to get right here. Look what we did. We added 4 on the outside. So now our vertex is 3, 4. Right there. Boom. 3, 4. That's how we move this. That's how we get from that parent function to those changes, those mini changes in the equation, getting us to that new absolute value function, moving it around. So what I'm going to do here is I'm just going to go through and I'm going to graph, starting with the parent function. I'm going to use my straight edge to do it. I'm just going to practice graphing all of these absolute value functions. Okay, that's what we're going to do today. It's just practice graphing all of these absolute value functions and making these changes in them. All right, let's get out the pens. Let's get out the pens, even that trash colored purple. Yes, Savannah, I said it. It's trash. All right, anyway, I'll start with my usual aqua, as that's what I usually take my notes in. So my parent function is y equals x. The vertex is 0, 0. The slope is 1. 0, 0. Slope 1 over 1, like this. And then you know this is your vertex, so just back the other way for your other points. Okay, that's it. That's all you want to do here. Arrow. Arrow. Label. This guy's going to be my parent function. Everything is going to move based on how this guy starts. So first move, let's make that a -1 slope. Okay, that's the first move. All right, fine, I'll start with your trash color of purple. So here, we just changed this to have a slope of -1. And what that really means is we have flipped the whole thing upside down. Okay, we flipped the whole thing upside down. So your vertex, notice, is still 0, 0. That hasn't changed. But now from here, from the vertex to the right, you go down 1 and right 1. And notice that ends up giving you this slope this direction. Well, of course, the other side of the vertex, you do the opposite. And then I use my straight edge to connect and cover my whole graph and do all the labeling and all the things that you know you're supposed to be doing. And there we go. Awesome. Label. And see, that negative out front just flipped us upside down from the original parent function. Ooh, let's look at C. I'm just going to zoom out slightly so I can still see all 4 graphs. And then when I flip the page, obviously, we'll look at those next ones. All right, what other color can we do here? Oh, I suppose maroon. Even though it is pretty close to purple, you guys are lucky that I wear this every Friday. Okay, let's see. Slope of 3, right? And still starting at 0, 0. So 0, 0. Now my slope is 3, positive 3. Up 3, right 1. Up 3, right 1. Look how much narrower I got. The other side of the vertex goes opposite, just like this. And now connect. Okay. So now y equals 3 absolute value of x is the label here. So now that slope, look at how much narrower it got from that original parent function that had a slope of 1. All right, let's see. We've used that, that. Oh, my aqua kind of got in the mix. Oh, let's go pink. The only color to wear on a good Wednesday. Now your slope. is 1/3. Okay, so this is actually going to be wider, much wider. Still haven't moved our vertex. Still haven't moved our vertex, but now we're only going up 1 and right 3. So look how wide this is. And look how much wider that is. And then on this side, it's the opposite. So up 1, but we're going left 3, and up 1, and we're going left 3 more, and connect that and look at that. There we go. Just like that. Okay, so look at those changes that we're looking at today. So far, we've only changed any slopes. We haven't even changed any vertexes yet. They've all been 0, 0 so far. So we've just been changing that number in front of the absolute value bars. So let's now do some more changes, maybe around the absolute value bars. So now we're going to start changing some vertexes. So let's take a peek. All right, let's mix some green in here. It's a +2 inside the absolute value bars. So that means it changes the x value of your vertex. So now my vertex is going to be a -2, 0. My slope, I'm just going to call it m over here, is a +1. So now if you look at all these, they're all going to have a +1 slope. So on this side of the page, no slope changes. So -2, 0. Kind of the opposite direction you think you're going to go, right? So it went left 2 from 0, 0. And then just up 1, right 1, and opposite for the other end. Now, with this one, it looks more like it's like a check mark kind of deal because it's not the center of my graph anymore, and I'm covering the whole graph, right? So it's just not the center of my whole graph anymore, and so it looks less V-ish, but that's just because I'm covering that whole graph. If I had stopped here, it would still be that V. But because I've got a whole graph to cover, I do it. All right, let's see. What else can I mix in here? A gold. Okay. Now look, can we see the gold? No. All right, we've got a -2 in here. That is a +2 as my vertex. Oh yeah, that shows up fine. And again, a slope of 1. So a +2, 0, up 1, right 1. So look at that. And again, based on the inside of the absolute value bars, the opposite direction of what we thought we would go from the original vertex. And now again, since it's not in the center, it looks like it's slightly off, but it's not. It's still a nice V. You know, if I had more graph, it would look a little bit cleaner. I don't like yellow either, just so you know. I mean, again, I pick on it less than I pick on purple because purple really upsets people when I say it's a trash color. But yellow ain't great either. That was moving left and right. Oh, wait, let me write that down. This moved right 2 from the vertex. We were left 2 from the vertex over here, right? Right, left? Get it? Okay, down here, let's see. How about orange? How about some orange? +2 on the outside. That is the correct place that you think it's going to go. So this goes from 0, 0 to 0, 2. This is up 2. And then, of course, your slope is still 1. But again, notice I have not had to stop to enter any of these into my graphing calculator because I know how the pattern works with looking at what I'm looking at in my equations. Can I? Sure. I can use that graphing calculator anytime I want, but it just becomes a little bit easier and quicker to just look at that equation and say, yeah, okay, I know how that guy's going to move. This one went up 2 from that 0, 0 vertex. All right, last one. Let's go for like a baby blue because I always use that aqua, but this one's a little bit different, right? Oh, that is not different. No. No, no. We're not just repeating that. Okay. Red? Red? This is now, again, the correct direction you think it's going to go, but in the y. So we're going to go 0, -2. So this is down 2, and again, slope of 1. So down here to start, if your slope is 1, you're still heading up positive direction in both directions, right? Like this, and connect, cover. Use that straight edge to connect, cover that whole graph. And label. And this guy we went down to from where you thought. So again, look at all those. Look at those equations changes and look how easy it is to figure out where's the vertex. What's the slope? Is it right side up, upside down? Okay. So here's where it gets really nice is if I give you an absolute value graph, you should be able to write the equation of it. Okay, you should be able to write the equation of it based on this. Okay, so we're just going to look at each of these graphs and we're going to write their equations. Now I want you to recall, okay, that the general form is y equals a times the absolute value of x minus h in absolute value bars plus k on the outside. A is going to be the slope. H is going to be the x value of the vertex, opposite sign of it. K is going to be the y value of the vertex, correct sign of it. All right, this guy's red, we'll write in red, right? Right. So here is clearly the vertex. So the vertex is 0, 0. So that's going to be very easy to plug in for those two pieces. They're both 0. That's going to be 0, that's going to be 0. But the slope is down 1, right 1. See that? So the slope is a -1/1, which means in front of my absolute value bars, I'm going to put a -1. Simplify all that down, you get, I'll write it out, the general, plugging in the general form first, and then I'll simplify it. So simplified is just y equals the negative absolute value of x, which of course we graphed on the other page. Okay, next. Oh, my aqua. How nice is that? They did my aqua for me. All right, vertex. This is left 1, 2, 3, so -3, and down 2, so -2, okay? And then from there, up 1, right 1. Yep, slope of up 1, right 1. So that's a slope of 1. Okay, so let me plug everything in generally and then simplify. So y equals 1 absolute value of x minus a -3. Now you can see why this is going to be a +3, minus 2 on the end. So because of it's minus a minus, y equals the absolute value of x plus 3 inside the bars minus 2 on the outside of the bars. So see that simplifying down? Now it makes sense why this is the opposite sign. Oh, purple. Vertex 0, 0. And slope of 1. Sure. This was the easy one. Y equals 1 absolute value, x minus 0 and plus 0. And so this is just our basic parent function of x equals the absolute, or excuse me, y equals the absolute value of x. And last but not least, this is looking orange enough for me that I think I'll go with orange. A vertex of 0, 0, but a slope of up 1, 2, 3, right 1. 1, 2, 3, right 1. Yep, my slope is 3/1. So let's plug in. Y equals 3 absolute value of x minus 0 and plus 0. So y equals 3 absolute value of x. That's a slope of 3. And that is how I want you to apply this on the homework. Okay? Is you'll also add, what we talked about earlier in chapter 1, domain and range. So you'll add those two pieces to it. But otherwise, You should be able to do this. Wait, am I lying about that? Oh, I'm lying about that. I was looking ahead on your homework. I'm sorry. You'll you'll be doing that when you do the review. Okay, not this homework, the review homework. But there we go. We're going to be graphing these, and then I'll give you a couple more pictures, and you tell me the equations. I will say, you do not have to write out plugging everything in and then simplifying. You can go straight to the simplified equation. That's fine by me. And normally I would, but we're not in person. And so, I want you to see my steps as to how I'm getting to that final answer. All right, guys. I shall be seeing you very soon. Have a wonderful day.